Hello guys, my name is Raul Vieira. I am an engineering student currently pursuing automobile engineering at India. I am a Cameroonian from origin. It is a new day, yes it is. And in this new day, I ask myself a series of questions like, what would the world become without engineering? What a world without technology? We see the world progressing from LED machines to CNC machines, from simple cars to driverless cars. In this slide, I have decided to open or establish a YouTube channel entitled VMS, Via Manufacturing Services. VMS aim at showing the world the importance of computer-aided design, computer-aided manufacturing, computer-aided engineering, and of course, computer numeric control, CNC. This isn't about me, but rather about us gathering all our ideas on a single platform entitled VMS. It is about VMS opening the world to manufacturing. It is about VMS showing the world the importance of design, manufacturing, analysis, testing and validation, of course. In this YouTube channel, I want to make use of a new method, of a new strategy in order to learn CAD, CAM and CNC. So rather of learning the commands, for example, if I come over here, File, New, Part, it's going to take some time to reflect. Okay, so rather of learning commands like line commands, circle commands, one after the other, we are going to be making use of projects. We are going to learn all these commands through the help of projects. I do believe that this is more effective than learning the commands separately. So we are going to commands first with CAD, CAM and CNC. In future, we are going to complete this particular YouTube channel with computer-aided engineering. So every Saturday, Sunday, you guys are going to be receiving a CAD and CAM video respectively. I equally intend to introduce 3D printing. So we are going to make about more than 50 projects, more than 50 mechanical design. We are going to design the project and then we are going to generate the M&G code using our CAM software. So later on, we are going to take the same CAD design and we are going to manufacture it rather by the help of 3D printers. Hopefully, my 3D printer will be set at that moment. So guys, I equally intend to open a Facebook page and Instagram page where I will send relevant information so that you guys can still keep going in the walls of this technology. So now, because one thing in CNC is, it's not just about generating the programming, it is equally about obtaining or having sufficient information about the tools. You could know how to generate the program, but with no concept about which tool to use, I can assure to you that programming is going to be wrong. Sometimes you enter the right instructions, but because of the failure or because the selection of the tool is wrong, you obtain wrong results. So tool selection is very important. I'm going to be sending relevant material, relevant documents so that you guys can follow with me. Equally guys, a website will be established and in this website you will be able to find all links that could help you to actually access my Facebook page, my Instagram page and even my email. You could ask me questions through Facebook or sending it directly to email. So what I intend is, if you have a particular assignment, if you have a project that you are doing and you are facing some difficulties, you could email me that project and I'm going to make the CAM part or the CAD part for you. And then I could present it as a tutorial or send it to you personally. So enough of this introduction. So with this YouTube channel, you are expected to gain skills towards CAD. In CAD, you will gain skills towards interpretation of engineering diagrams, 3D design skills, assembly skills, and indeed creation of fixtures. As we do all know, when you are working with a CNC machines, fixtures are being required. You need to hold the working piece together before any operation is being done. 2. With CAM, on the side of CAM, you expect to get skills towards understanding the tools in CNC. You will obtain skills towards generating the M&G code required for the mechanical part. And again, you are going to obtain skills towards troubleshooting of the M&G codes. Troubleshooting is very important. Now, why do we say troubleshooting? I want to tell you guys that solid CAM or CAM softwares in particular are not perfect. They do have limitations. So sometimes you need to troubleshoot this the M&G codes. You need to troubleshoot your program. So we are going to be using Simco Editor for the troubleshooting. Nevertheless, later on we are going to be working with computer-aided engineering, where we are going to analyze some mechanical parts. We are going to be applying some forces and looking at points where the material breaks. We are going to be applying some gravities to the mechanical part and seeing what happened. We are going to be applying some frequencies and seeing where actually the material deforms or fractures. And at last, we are going to be working on rendering. Rendering is actually a very important process. You can make your project, you make series of projects, but the presentation matters. The way you present your project, it matters a lot. The way you present your project on your portfolio, on your CV, or whatever matters a lot. The color or the texture you use matters a lot. We are going to be using SolidWorks Visualize in order to do this. SolidWorks Visualize in order to make our rendering process. It's very important. I'm putting this at the last. This will be the last thing we are going to do. I'm going to select 10 best projects, or you guys are going to select 10 projects of your choice, and we are going to make the rendering with those projects. To round up, we are going right now to make an introduction about SolidWorks or SolidCAM interface, and then we are going to look upon SolidCAM settings as the first tutorial. So let's get started. So basically, this is the interface of SolidWorks. Being it's written here SolidCAM, but it's just that my SolidWorks and my SolidCAM are being embedded together. That is why it looks this way. Okay, but nevertheless, if you open your SolidWorks, the interface should look exactly this way. Okay, so you are going to see sketch. So basically, we have to start with a sketch. Definitely, we have to select if we are working with the top view, side view, front view, or bottom view. Definitely. So as you can see, front view, top view, right view, even bottom view could be selected. Okay, so if I just come over here, sketch, you see you could select the views and even the bottom view. So we are going to go with the commands through the help of projects. So I just want to make one thing. I just want to close the software and reopen it back. Just a moment. So right now I want us to discuss about SolidCAM settings. We need to see what are the settings, what are the options we got when we are using SolidCAM. So it's gonna take some time. Okay, good. So you just come over here, SolidCAM settings. Okay, so now we have the user directory. So the user directory, it's actually a folder where all your CAM projects are going to be saved. So this is, it's automatically selected to my document. So you could change it just by coming here, you browse. You could come to, let's say, desktop, you make a new file, and then you could say, okay, let me just a moment, let me renew. Okay, you could say, let's say, SolidCAM projects, and you just go for the okay. But right now I'm just gonna cancel it. I just like the default my document. Okay, so we have units. The units are very important. You should make sure that you are either working in metric or inches. When we say metric, we mean millimeters. You need to be aware of the unit you are working with. Now we have the default CNC controllers. We got many CNC controllers. It's very important you select the right CNC controllers. As default, we have G Milling 3X, but when you are going through the CAM software, you could still select your controller. It doesn't mean that because this is default, you are going to walk through with this. No, there's an option to enable you to reselect the CNC controller. So this is just a default. Okay, guys? So the selection of the controller is very important. If you are using a Fanuc CNC, for example, and when making a CAM project, you use, let's say, G Milling 3X, I can assure to you that you are going to mess up, because there are some M&G codes being recognized in Fanuc which are not recognized in G Milling 3X. Hope you got the point. So something again, CNC, or let's say, CNC systems are subdivided into two main parts. We have milling and we have turning systems. So milling and turning. In between it, we have what we call mill turn. So we are going to start with milling CNC controllers. Later on, we are going to move to turning CNC controllers, and finally mill turn CNC controllers. Okay, we have the G codes. So now when you are done giving instructions to the machines, when you are gone giving the tools, giving instruction, setting up the tools, telling the machine how to do the job, how to machine the piece, you got to generate the M&G code. So how do you generate this M&G code? So now when you are done with the program, there will be an option, generate M&G code. Actually, there are two options: generate M&G code, option 1, option 2, generate M&G code with time. So it means it's going to show you the M&G code and the time it took to make the full operation. Okay, so now there are two things. It's going to generate the code. It can generate the code in a Microsoft Word document. It can generate the code in a Notepad document. It can generate the code in what we call Simco editor. So right now, if you come here, editor for the G code file. So it's by default, it's taking Simco editor, and I'm going to advise you guys to take the default Simco editor. Now, when you are using CNC machines, maybe let's say of 3-axis or 4-axis, it happens that there are some limitations or some mistakes that can happen, you know, in the generation of the M&G codes. The mistakes aren't from the side, but they are from the side of the software. Now, a common mistake is the origin of the software, of the CAD software, is not the same origin as the CNC machine. Just think about it. The origin point of the CNC machine and the origin of the CAD software can differ. Now, if this happens, there will be a mistake, or the M&G code will have some errors. So in order to rectify this error, we use what we call Simco editor. Hope you got my point. So later on, when we are going to be using, you know, high CNC controllers, we are going actually to use Simco editor. I'm going to show you guys examples where no error occurs, and I'm going to show you guys examples where errors occurs and how to fix these errors. So this will be the troubleshooting. Okay, so I'm just showing you guys the basic settings. Okay, now there's a basic question. We have this thing known as iMachinery. Why solely CAM? We got many CAM softwares. Why did I in particular choose solid CAM? Why not Power Mill? Why not MasterCAD? And why not Fusion 360 CAM? Now, solid CAM introduces a new concept known as iMachinery. iMachinery is actually an improvement on all the operations. When I mean improvement on all the operations, I really mean improvement on all operations. Now, to machine a part, it can take 10 minutes just to make a hose. Let's say, you know, if the hole is too deep, it could take, let's say, 5 minutes. If it takes 5 minutes to actually make a hole, with iMachinery, with the help of iMachinery, that 5 minutes is going to be reduced to say 2 minutes. So it's beautiful, meaning that it saves production time, meaning that you work more faster. And it's not just about production time, it has a high precision and accuracy. So for this reason, for this improvement, for this additional iMachinery, SolidCAM is one of the best CAM software or CAM company in the world today. So that's why right now I'm using SolidCAM. Equally, we have tolerance. I want to speak about tolerance, and this will be the last settings we are going to speak for this tutorial. Tolerance is very important, guys. It's very important because with the tolerance, it determines how precise you are. It determines how accurate you are. Now, the lower your tolerance, the more accuracy. The lower your tolerance, the more precise you are. The higher your tolerance, the less precision. So, but you should also understand that this is a software, right? So, the lower your tolerance, the more precise you are, the more accurate you are, and the more your software freezes. So guys, I hope I was able to show you guys or make you guys understand the importance of tolerance. Actually, tolerance is highly important. If you see any engineering sheet, when I mean by any engineering sheet, I mean this. Let me just show you guys a sample. Okay, let me just view this. So normally this could be the engineering diagram. They can give you a diagram like this, and you are required to draw the isometric view. It means you have to interpret this to this sketch using your own knowledge. So as you can see here, let me just zoom it, please. Just a moment. Okay, good. So as you can see here, the manufacturer can actually precise the tolerance. You must work within this tolerance. If the hole has to be 40 millimeters, it should be within this tolerance, that is 40.025. If it is 40.026, then the hole is wrong. Then he will not buy the product. I don't know if you are understanding my point. You should be within the tolerance. If you get a hole of 39, then you have messed up the product totally. Because imagine if the hole has to be 40 mm and you have a hole of 41. That means you have the ability to still reduce it using a boring tool. Okay, but if the hole is 39, you can't increase it again. So it means that part is spoiled. You have wasted money. So tolerance is very important. You don't have to play with tolerance. So to be on the safe side, tolerance goes with tool. Once you select the right tool, once you use the right operations, therefore I can rest assured to you guys that the tolerance is gonna be beautiful. Okay, let me just zoom this back. Okay, so we are actually done with SolidCAM settings, the basic at least. So in the further tutorials, we are going to be going through more of these settings as times go by. So I hope you guys can see my screen, and I hope you guys see this beautiful mechanical part. So this will be our first project. This will be our first project. We have to actually interpret these sketches and draw this particular part with a high precision. Okay guys, so this project is known as VMS Project 1. This will be our project 1, and we will begin this in the next tutorial. So I just want you guys to remember that VMS is aimed at opening the world towards manufacturing. So guys, I highly appreciate your subscription, and for sure just clicking on the notification button, clicking on the like button, following me of course on Facebook, Instagram. As I later on said, important files are going to be shared through the Facebook page. Your relevant information about manufacturing, about why considering manufacturing as a career objective, are going to be shared on our Facebook page. They are going to be shared on our Instagram page. So kindly follow us, kindly keep working towards your objectives, and it's going just to be marvelous. So in the next tutorial, we are going to be attempting VMS project 1, and hopefully we are going to be successful. So guys, just expect a CAD video every Saturday and a CAM video every Sunday. Like you guys, and of course do not forget to subscribe. Thanks a lot. Boom.